Hi, this is Alex from devstories.eu. LangGraph, episode 4 of 18. Sometimes you just want to write a standard Python script with normal if statements and for loops, but you still need enterprise-grade state persistence. You do not want to construct an explicit state machine just to run a few language model calls in sequence. This is where the functional API, specifically the entry point and task decorators, resolves the tension. Building applications with explicit nodes and edges requires you to manually define how data routes from one step to the next. That structure provides immense control, but it can feel heavy when your logic is highly sequential or relies on standard programming loops. The functional API allows you to write normal, top-to-bottom Python code while retaining built-in streaming and recovery features. Instead of instantiating a graph object, you apply decorators to your existing Python functions. You start with the task decorator. You apply this to the individual units of work in your application. Think of a task as a discrete step that does something specific, like querying a database, calculating a metric, or prompting a model. When a function carries the task decorator, the framework wraps it in a tracking layer to monitor its execution. Next, you use the entry point decorator. You place this on the main orchestrating function that directs the overall flow. Inside this entry point function, you call your decorated tasks using standard Python control flow. You assign the output of a task to a variable, then pass that variable to the next task. You can use try-except blocks, list comprehensions, or while loops. The orchestration logic behaves exactly how native Python behaves. Because the code looks entirely standard, you might assume it locks the memory of a formal state structure. This is a common misconception. The functional API still automatically checkpoints your progress behind the scenes every time a task completes. LangGraph intercepts the return value and saves it to a persistent store. The framework securely records the inputs and outputs of every decorated function as they happen. Consider an automated essay writing script. You define 3 decorated tasks: an outline to generate an outline, a function to write a paragraph, and a function to review the draft. Inside your main entry point function, you call the outline generator first. Next, you write a standard for loop that iterates over the sections of that outline, calling the write paragraph task for each one. You append the results to a local list. Finally, you run the review task. You use a simple if statement to check the resulting score. If the score is poor, your code simply triggers a while loop to rewrite specific paragraphs until the score improves. Here is the key insight. Because of the hidden checkpointing, if your script encounters a network timeout while writing the 3rd paragraph, you do not lose your work. When you restart the process with the same thread identifier, LangGraph knows the outline and the first 2 paragraphs are already complete. It skips executing those tasks entirely, retrieves their cached outputs from the state store, and resumes execution precisely at the 3rd paragraph. The functional API shifts the cognitive load from visualizing abstract routing topologies back to reading code top to bottom, giving you the resilience of a state machine with the simplicity of a plain script. That is all for this one. Thanks for listening and keep building.